Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss call of a vector function. Let's begin. The call of a vector function, let f be a vector, then it is represented by grad cross f vector. This one is known as the call of a vector function. As we know, the del operator, that is grad vector, is represented as I cap del by del x plus j cap del by del y plus k cap del by del z cross I cap f of x j cap f of y plus k cap f of z is equal to, we can write, that is I cap j cap k cap del by del x del by del y del by del z fx fy fz determinant. Now we expand that determinant. We find I cap del fz by del y minus del fy by del z plus j cap del fx by del z minus del fz by del x plus k cap del fy by del x minus del fx by del y. Look at I cap, j cap, k cap. That's why which is a vector quantity. The result of that of a call of a vector function is also a vector function. Is also a vector quantity. That's why the call of a vector is a vector. Now we have to understand the concept. What is the physical meaning of that of call, or what is that of a geometrical interpretation of that of call in physics? Let us start. Physical meaning of call. To derive the physical meaning of call, we have to introduce, let f vector is represented as I cap f of x j cap f of y plus k cap f of z be the vector point function having the component fx, fy and fz, which is along x axis, y axis and z axis respectively. Let del fx by del y del fy by del x, this represents the rate of change in fx, that del fy by del x is the rate of change in fy, which represents with respect to that of y axis, and that is with respect to x axis. Let us draw a figure. ABCD is a rectangle. The distance, let it be dx, and dy be the two sides of that of rectangle, and the area of that of rectangle is dx into dy. This is very small. Here look at the figure. The value of x component along AB and CD are f of x. Can write the value of x component along the path AB and CD are f of x along AB, that is f of x, and along CD. CD is just opposite of that of AB, and which is a distance of dy apart. That's why that is f x plus del f x del y into dy respectively. F of x is the x component along the path AB, and f of x plus del f x del y dy is the x component along CD. Similarly, the values of y component of the vector, what is that vector? F vector along y component means that is along DA and BC are f of y and fy plus del fy by del x into dx respectively. As we done in that of a previous, that is the y component of that of vector f along DA is f of y, and along BC the f of y plus del fy del x into dx. Now the line integral, now we write the line integral of f vector around the rectangular path ABCD is given by, we can write that is fx dx plus, look at the figure, we are proceed like this, AB, BC, CD and DA. AB direction is just opposite that of CD. For that reason we introduce a negative sign in case of CD, and also BC is the opposite to that of DA. That's why we also introduce a negative sign to that of the line integral path dA, f of x dx fy plus del fy del x dx dy minus f of x plus del fy by del y dy dx minus f of y dy. We introduce minus sign as these are opposite to that of direction. Solving this, we have get del fy by del x minus del fx by del y into dx dy. This is the line integral of that of vector around the rectangular path ABCD. Here dx dy is the area of that of rectangular path if we consider the area is unit. That's why what happened? Hence we can write, hence the line integral of a vector per unit area perpendicular to z axis is, as we find out the result, this quantity dx into dy is equal to 1. That is del fy by del x minus del fx by del y, which is nothing, we can say curl of f vector, curl of f vector to which? To xy plane, as we consider that is perpendicular to z axis. That's why this quantity is the curl of a vector to that of xy plane. That is, we can write curl of f vector perpendicular to z axis is equal to del fy by del x minus del fx by del y. Similarly, curl of f at perpendicular to x axis and curl of f perpendicular to y axis is given by curl of f vector to that of x, that is del fz by del y minus del fy by del z, and curl f vector perpendicular to that of y axis del fx by del z minus del fz by del x. Now we have, therefore we can write curl f, that is I cap curl f x plus j cap curl f y plus k cap curl f z. Now put these values. Curl of f vector is equal to I cap del fz by del y minus del fy by del z plus j cap del fx by del z minus del fz by del x plus k cap del fy by del x minus del fx by del y, or curl of f vector is equal to, that can be written as I cap j cap k cap del by del x del by del y del by del z fx fy fz determinant. This is nothing but we can say, that is the grad cross f is that of curl, where grad I cap del by del x j cap del by del y plus k cap del by del z. Hence the magnitude of that of curl, we can write, hence the magnitude of curl vector, curl of vector point function, curl of vector point function is the maximum, value, what maximum value of line integral of the vector, line integral of that of vector point function, per unit area along the boundary of plane area, that the plane area is very small. This one is the physical meaning of that of curl. The magnitude of a curl of a vector point is the maximum value of the line integral of the vector function per unit area along the boundary of plane area. That area is very small. This one is the physical meaning of curl. For that of note purpose, we can write, if that curl of f vector is 0. In that previous case we studied about, if that gradient of a vector is 0, then we say that the vector is a solenoidal vector. But at that case, if curl of that vector is 0, then f vector is an irrational vector, irrotational vector. In physics, there will be so much significance of that of curl, as we discuss the vectors like gravitational field, examples like gravitational field, and electrostatic field, are such vectors are under the category of irrotational vector, as its curl of that of vector is equal to 0. This one is the note. To find out the condition to a vector is said to be irrational. That means if that call of that vector is 0, then we can say that vector is irrotational. That's why some physical quantities like gravitational field and electrostatic field are some examples to that of irrotational vector. So with the help of this video lecture, we studied the concept of call of a vector function and its physical meaning of that of call. Finally, we get a note regarding how we behave or how we categorize a vector is said to be irrotational by using the concept of call. If call of that vector is 0, then we say that vector is irrotational vector. And some examples like gravitational field and electrostatic fields are the examples to that of irrotational vector. So with these valuable notes, let me wind up this session. Thank you.